All right, here's a Unit 5 semester exam review video key on trig. If you're watching this in the year 2025, we did not talk about cosecant, secant, cotangent, but I will explain what they are. But in any case, from a given triangle here, if you're going to find sine, cosine, tangent, you need to find the third side from Pythagorean theorem, which is done right here. And then from there, sine, you probably know the acronym SOHCAHTOA. So sine is opposite over hypotenuse. So if you're doing sine of D, here's angle D. Opposite means across from it. And then hypotenuse is 29, so 20 over 29. Cosine of D is adjacent, which means next to, so 21 over hypotenuse 29. And tangent is opposite over adjacent. So opposite over adjacent, 20 over 21. And then same things here, just with angle E instead. And so opposite, sine of E is opposite over hypotenuse. Cosine is adjacent to angle E, which is 20 over hypotenuse. And then tangent is opposite over adjacent, 21 over 20. Okay, same thing going on here in this picture. Except on this one, you're just given the fact that tangent of A is 3/4. And so you label your triangle, this is opposite over adjacent. So opposite is 3 over adjacent. Adjacent to angle A is this one, 4. From Pythagorean theorem, you get 5, and then you can write these from there. What cosecant is, I'll write these out for you real quick. But cosecant, which is spelled like this, is just the reciprocal of sine. Secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. And so once you know these three answers are just these answers flipped. So as long as you know what pairs with what, they're really easy to do. All right, now we're going to find missing angle measures or side measures, depending on the problem. Here we have this angle, and from this angle, we have the adjacent side and the hypotenuse labeled. So if you have adjacent hypotenuse, you're going to use cosine. So it's cosine of 63 degrees is equal to adjacent over hypotenuse. That's what this is here. And then to solve this, you just multiply both sides by 16. Remember, cosine of 63 degrees is something you can get from a calculator or Desmos. Just make sure you're in degree mode. Number 4, you can use cotangent, but again, we didn't really talk about that. So we're going to use tangent because we have the opposite and adjacent sides compared to angle 39 degrees. So you do tangent of 39 degrees equals the opposite over the adjacent. Notice how when you use cotangent, this is just flipped because that's what cotangent is. It's the reciprocal of tangent. But to solve this green one, you just multiply both sides by x. This math is always the same, so it's not very difficult. You multiply both sides by x, and then divide both sides by tangent of 39. So in the end, you get x equals 27 divided by tangent of 39 degrees. And you can just type this on a calculator, and it gets you your answer, which will be the same as this answer. Okay, and then over here, again, we have an angle measure. We have the adjacent hypotenuse. So you set it up as cosine of 15 equals adjacent over hypotenuse, and then to solve, multiply both sides by 33. On number 6, we have compared this angle, we have the opposite and the adjacent. So use tangent. So tangent of 52 is opposite over adjacent. Multiply both sides by 20 to get that answer. Number 7, we have opposite and hypotenuse. So that's going to use sine. So use sine of 27 degrees is 5 over x. Again, this key uses cosecant, which is just the reciprocal. The reason the key was made this way is because if you use cosecant, then the x is on top, which makes the algebra easier to solve for x. But we can still do it. From the green equation, just multiply both sides by x. So you get x times that. And then our x's cancel on the right side. And then divide both sides by sine of 27. So x equals 5 divided by sine of 27 degrees. Remember, this is just a number that your calculator gives you. So that's like what we saw earlier. Same algebra from an earlier problem. And then on number 8, we have this angle, the adjacent, and the hypotenuse. So do cosine of 54 degrees is adjacent over the hypotenuse, multiply both sides by 12. Now on these problems, you're finding the angles. So you set it up the same way. You have an angle, you have the opposite, you have the adjacent. So you're going to use tangent of x degrees is equal to opposite over adjacent. And then to get x by itself, you do tangent inverse of both sides, which is what this is. So you just do tangent inverse of this angle, and that will give you what x is. Okay, so I'll show that set up on all these. On 11, sorry, I'm going to go down here instead of right, but we have this angle, we have the adjacent and the hypotenuse, so that's cosine. So you do cosine of x degrees equals 25 over 40. To get x by itself, do cosine inverse of this, which is what this is showing. On 10, we have, for this angle, the opposite and the hypotenuse, so it's sine of x degrees equals 12 over 54. And so you do sine inverse of 12 over 54 to get x by itself, which is what that's showing. And then finally, I'll let you think through this one, how you would set up tangent initially, but you can see the work that you would show there. All right, on 13, we're a few word problems here. Max built a skateboarding ramp that is 16 inches high, so that means vertical distance here. The angle formed by the ramp and the ground, so here's the ramp, here's the ground, is 21 degrees. What is the length of the ramp? The length of the ramp being this. And so we have this angle, we have opposite and hypotenuse, so that's going to be sine. So sine of 21 degrees is equal to 16 over x, opposite over hypotenuse. Multiply both sides by x, divide by sine of 21. Again, using cosecant here is not something we talked about, but you can always just do it this way instead. Let's see, 14, a fireman leaned a 36-foot ladder right here against a building. Here's the building. If he placed the ladder 7 feet from the base of the building, so this is 7 feet away, what is the angle formed between the ladder and the ground? So this angle. So now we're searching for a missing angle. We have adjacent and hypotenuse. So that means we're going to use cosine. So cosine of x degrees is 7 over 36. Once again, to get x by itself, do cosine inverse of both sides. And finally, Casey sits at the top of an 84-foot tall lighthouse at an angle of elevation of 58 degrees. If Casey is 6 feet tall, how far is he standing from the base of the lighthouse? Sorry, Casey sights the top. So basically on this problem, we're making it a shorter triangle. If Casey is 6 feet tall, really should be 6 feet to his eyes, I guess, where he's looking. But this is 6 feet. The whole lighthouse is 84 feet. And so really we're starting the lighthouse at 78 feet, 6 feet less because of his height. And so then you have this triangle. This angle is 58 degrees. And we're trying to find how far he's standing from the base of the lighthouse, which is what's labeled as X in that picture. And so we have adjacent and opposite, so tangent. So you do tangent of 58 degrees equals opposite over adjacent. And then to solve for x, once again, you multiply both sides by x over here, and then divide by tangent 58. So 78 divided by tangent 58. And that gets you that answer. And that's it.